So I've given the Bihar State exam, and today I'm discussing the questions for which I've answered something and whether those answers are correct or not. And today I will be taking the help of ChatGPT also. So which type of a counter uses a feedback mechanism to achieve non-sequential counting? Uh, it means that we want to get a non-sequential counting, right? And these are all the counters, right? So yeah. So I've asked this question to ChatGPT. So these are the four counters. Non-sequential basically means just after one, two won't come, three can come or any other number, but two should not come or zero should not come, like that. So it should not be in a sequential manner. Yeah. So it says the Johnson. So it says the correct answer is Johnson counter. I also gave the Johnson counter answer, but somehow the state board is saying that ring count is the right answer, and it's written that this Johnson counter, it has 8 unique states, but none of it is sequential, and that's with the sequential that is. Yeah. But for ring count it says there are four unique state. This is 8. This is 6. This is 4. This is 1. So maybe this is what it means to be sequential. Like just so anyways, like one is shifting um, from right to the left, right? So it's a sequential, or you can say vice versa. So this is sequential. A counter is sequential. If you see here, 0, 1, 2, 3, like that. Down counter is also again, this is 15, this is 14, this is 13, this is 11. So this is also sequential. So yeah, these two can be an answer, but the best answer would be Johnson counted, because there is no shifting of bits also. Okay, now coming to the next question. So the answer should actually be Johnson counter. In SR flip-flop, the SR flip-flop can be used to create a 2D flip-flop by connecting its inputs in each bit. Okay. Used to create flip-flop. Okay, so these are the questions. So it's the correct answer is equal to d dash r equal to d, and I've given, okay, my answer was s equal to d r equal to d dash. It's actually the opposite. Why? So let's see. So in SR flip-flop, it's a set preset flip-flop. It has two inputs s and r, and two output q and q dash. The behavior of the flip-flop is defined as follows: when s is equal to 1 and r is equal to 0, the flip-flop sets, okay, making q1 and q0, when s equal to 0 and r equal to 1. The flip-flop resets making q0 and q1. Okay. S0 R0, the flip-flop returns its previous state. Okay. Okay, so set and reset basically is, and the condition is 1 and R1 is generally avoided as it can lead to an undefined state. Okay. Okay, let's see what is a D flip-flop. Data delay flip-flop is an input D and captures the value of D on the clock edge, reducing it at the output. Okay, conversion of a sub flip-flop to D flip-flop. Converters of an sub flip-flop to D flip-flop. Operating inside when D is really flip-flop. Set status is equal to output is equal to 0. The flip-flop set status. Okay, so it says that when D is 1, the flip-flop will set. That is, it will make S1 and R0. When D is 0, the flip-flop resets, that is S becomes 0 and R equal to 1. So Okay, so SAD and R equal to D dash won't produce the desired D flip flop, but this S equal to D dash and R equal to D will produce the desired D flip flop. Okay, now coming to the next question, which of the following is a binary number? Uh, so you, this is a very easy question actually. Which of the following is a binary number? Binary number is 0, 1, 0, 0, or anything like the number which has values between 0 and 1, right? So binary means basically 2, so any number below 2 is binary. Decimal means starting from 10, right? So any number below 10 is decimal. um, and octal means 8, so any number below 7 can be an octal. Hexadecimal means any number below 16 can be a hexadecimal. So we are talking about binary, right? So any number between below 2 can be a binary. So this one is below 2, 0 is also below 2, so we can say it is a binary. How many bits are used to represent a single decimal digit in Gray code? How many bits are used to represent a single decimal digit in Gray code? Okay, let's see what the answer for this is. Anyways, my answer is we have to represent a single decimal digit, right? Decimal basically means below any number below 10, right? So you have to represent a single number below 10, so it can be 9 also, right? So if a number is 9, you will need actually at least 4 bits. And yeah, let's see what is the answer for this. How many bits are used to represent a single decimal digit in Gray code? Okay. Mm, okay, yeah, I mean we can't use 5 bits, right? So actually it is correct, we have to take 8 bits. Gray code, also known as reflected binary code, is a binary numerical bits with two successive values differing 1 bit. It is commonly used in when it is string the transitional states. Okay, so these are the states. So for 8 we need 4 bits, right? But in order to show 9 we need a single decimal is from 0 to 9, which can be represented in binary as follows. To represent any of the decimal digits in binary, we need 4 bits. Gray code for decimal digits. Gray code representing it's the same, right? Okay, no, it's different. It still says that actually this is wrong. It has to be similar to. So it says the 8 bit is wrong. 4 bit has to be the correct answer. And how do you get? Okay, the way to get to get the gray code for 3 is we first have to get the binary equivalent of 3. So the binary equivalent of 3 is this one, right? Now we have to do sort by just by the by its successive number, right? So 0, so 0 will be written as it is. Just after 0 there is another 0, right? So XOR of 0 and 0 is 0 itself. So we'll give it as 0 comma 0. Now coming to the third part, so there is a 1, right? So XOR of 0 and 1 is 1, right? So we get another 1, but XOR of 1 and 1 is 0, so we get 0. So similarly, in order to get the gray code of 9, right? So 1 will be written as it is, so 1 and 1 XOR of 1 comma 0 is 0 1, right? And another again, then 0 XOR 0 is 0, 0 XOR 1 is 1. So this is the gray code equivalent. So this is what is written here. Each subsequent bit of the gray code is obtained by XORing the bind is obtained by XORing the current binary bit with the previous binary bit. Okay, yeah. So the example is also given actually. We do a XOR of that particular number with its previous number. Okay, so the answer has to be 4 bit, but they are saying okay, so I have sent it is a 8 bit, but it has to be 4 bit. Okay, okay, sorry, my fault. Now coming to the next part, in 4 bit binary added subtractor circuit, if the control input is set to subtraction mode, which operation will be performed? So there is no subtractor actually, it's just the adder, and using an adder itself we can just do a subtraction. So in order to do a subtraction, right, we first convert the number to its 2's complement and then just add it. So when we add a number with any number which is our 2's complement, right, it actually does a subtraction. So and it actually says key, if the control input is set to subtraction, which operation will be performed, right? So that's a subtraction. Let's see what ChatGPT says. Okay, so 4-bit binary adder is device to do addition and subtraction on 4-bit binary numbers. The operation determined by its control input. M, M is 0 means addition, M is 1 means subtraction. Subtraction using 2's complement. As I said, we first have to do a 2's complement. So 2's complement of the binary is obtained by converting all bits, taking 1's complement, then adding it to the first least significant bit. Subtraction is also simple. Uh, yeah, I mean, so these are the two numbers, right? Let's say we want to do a minus b, right? So people have to first invert b. So 1's complement of b is this one. Then we add 1 to get the 2's complement, and then we add it to a. So basically we will add this uh, to this one to get a minus b, and yeah, that's it. uh, yeah, so this was right for me. An encoder is used to, so okay, encoder, as the name suggests, right, we want to encode something, right? So if we want to encode something into something, right, so when we want to transfer some data, right, encode binary information into a smaller set of bits. Hmm. So why we need encoder? In order to transmit something, right, we can't just transfer the whole object as it is. We'll have to convert it into smaller chunks, right, and that smaller chunks is actually bits, because byte is a bit binary information is a bit big, right? So let's say you want to transfer a video, right, using Bluetooth. So in order to transfer the data using Bluetooth, we actually transfer it using in terms of bits, and we won't be transferring it in a large set of bits, right? Because what's the point of encoding it if we are going to transfer it in in one go, right? So Anyways, let's try uh, ChatGPT's answer. What they say. It's a combination circuit. Okay, it converts information from one format to another, typically from a more recognizable format to a more compact or efficient form. Okay, so now we have the use case. So data compression. Uh, it is basically used for data transmission, right? So yeah, converting decimal to binary. So yeah, binary to binary coded decimal. So this was binary code, and the question was okay, and so yeah. Now coming to the next question, which statement accurately describes a programmable logic device? Okay, as the name suggests, right, it's a programmable logic device. So programmable. So it's something which requires some programming, like something related to that, right? So it says accurately describes, right? uh, it says that it can only be programmed once and cannot be reconfigured. Then if the name suggests programmable, like it can be programmed, right? So I think it has to be multiple times. It can't be like once only. Can we use logic device, programmable logic device to store are used exclusively for memory storage decisions? Exclusively means like it's just PLDs are used just for memory storage in digital circuit. I don't think that's the case, because if it was used for just memory storage, then why the name programmable? Uh, so this might be an answer. And program PLD consists of only AND gates and do not include OR gates. Now this is wrong because we all know most of the gates are like mostly made up of NAND gates, right? NAND or NOR gates, or basically universal gates. Uh, yeah, because NAND and NOR gates are only used to store data and all, right? So we can't just use AND or AND gates to store the data. Yeah. Okay, let's see ChatGPT answer. So three is the answer which makes more sense. So because for each program, right, we need some input, and the reason why we write program is basically to get some output, right? So that is why we need to implement custom logic functions. Logic function means basically you are writing some code. Let's see the answer from ChatGPT. So it's written here, a PLD can be programmed to perform a wide variety of functions. Use case development. Ability to implement custom logic functions, programmability. It can be programmed using hardware description language. Okay. Now going ahead. In binary subtraction, if a negative binary result is obtained, what can we do to obtain the positive result? Okay. If you have a negative number, right? Okay, so if you have a negative number, we'll just inverting all the bits in the result, bring the number as it is. The answer will be no. So add 1 to the result, subtract the result from 0. I mean, if you subtract the result from 0 again, you can get a positive number. Divide the result by -1. Now here I need ChatGPT answer because most of the answer makes sense. So we want to get a negative number. Sorry. So we have a negative number. Uh, negative number basically has a one in the most significant bit. So basically, I am talking about number like this 11001. So basically, this means that the number is -1. Yeah. What can be done to obtain the positive result? Options are this. In binary arithmetic, when dealing with negative result, the concept 2's complement to represent negative number. So basically, we use 2's complement to represent a negative number. If a negative number, and you want to the corresponding positive value. So we just have to convert a 2's complement number into its positive value, right? We need to convert the negative number back to its positive form using following steps. We first have to invert all the bits in the result. Add 1 to the inverted result to obtain the 2's complement. So invert all the bits called taking add 1 to the result. So none of the options make sense actually. Okay, what is the question? What can okay? It's not saying ki. It is not saying that if you just do all the steps, you will get a positive number. It just means to say ki it is a part of process. So yeah, we first have to invert all the bits, and we also have to add 1 to the result actually. So none of the options make sense actually. Which alphanumeric code is so none of the option alone is correct. But if you want to if you want to choose part of it, then I would suggest invert all the bit first, then add. So maybe that's why they are saying invert all the bits is the result. Which alphanumeric code is most commonly used for representing text characters? In English, alphanumeric code is most commonly used for representing text characters in English and many other language computer system. Hmm. So yeah, so the question is which alphanumeric code? So basically there is a character right in English. We want to understand key English alphabet for English alphabet which of these codes can be used. So the answer is Unicode. So ABCDIC is a extended binary coded decimal interchange. So it's just for it has a it has its to represent a wide range of characters from different languages. And the question is alphanumeric. It is for representing text characters in English. But it still says ABCDIC is limited. Hmm. But it is now not used in modern computer. Okay, Unicode. So Unicode is something which is used in all the computers, and you can use that. Access code is also not the right answer. Gray code, as we saw earlier, right? Just numbers getting converted into like into some binary form again. What is the gray code equivalent of the binary number 0100? So this is simple. 0 0 0 1 becomes 1, 1 0 becomes 1, and 0 as it is. Gray code, it's asking gray code, right? So 0. Let's see what ChatGPT says. So the correct code equivalent is 0110. My answer is 0110, but they are saying 0011. So I think that the answer given is wrong by the Bihar School Examination Board. Another question: in a microcomputer system, what does the address bus facilitate? Hmm. So if there is address bus, right? Address is basically stored off memory. So we want to get to the memory from the CPU. So the correct answer is to get access to the memory from the CPU. So addressing memory location means the address bus carries the address of the memory location where data is to be read from or written to. For example, CPU wants to read data from memory location. This address bus will carry this address to the memory. So yeah, I think I did this on which company introduces the first commercially available packet processor? The Intel 404 in 1971. I mean, if the chip name is Intel itself, I think it has to be Intel only, right? There's no other option. This is like a simple answer. T. Morgan's first theorem states that the complement of dash of variable is equal to the of their individual complements. This was a tricky question. I had to think what it means. So it means that states that the complement of a or of variables. So we want to do a complement of or of variables. So a plus b, and then there's a complement on top of all of it is equal to and of their individual the complement of is equal to complement. Yeah, yeah. So this is what it means now. So if you do a plus b whole complement, right? Uh, you will get a and is equal to the and of their individual complements. So yeah, a and b but individual complements. So this was correct for what is the main trade-off in time space. What is the main trade-off in time space trade-off? Time and so yeah. So what is the main trade-off in the time space trade-off? So it means that when you want to reduce your time complexity, right? You basically go into higher into taking more space, and if you go into reducing the space, it actually takes more time. So it can't be increasing both simultaneously. It has to be opposite. This not yeah, this might be the right answer. So yeah, I mean we can't say the vice versa actually. So sometimes what happens is if you're trying to improve the space complexity, right, it doesn't mean कि every time your time complexity will decrease, right? So third is the right answer. Which property of big O notation states that if f of n is big of gn, then k star k into fn is big of gn for any positive constant k. Let's ask ChatGPT because I am also not sure what it means. It was just a hard guess. So the answer they are saying is multiplication. Okay. If you multiply fn by positive constant k, the number the new function k into fn will still be bounded by c of g and adjusted by the constant factor k. So they are saying k into fn is actually equal to k into c into g. Good. Let me read again. So then fn is equal to big of o of gn. Then saying k into fn is again big O of gn for any positive constant k. Okay, so the constant is k, right? So yeah. So the answer is multiplication. I think we will just have to learn it. The recurrence equation dn by 2 is represents the time complexity of which algorithm, right? So if you see here, right, it is actually getting reduced by half every time, right? So this is basically divide and conquer, and the time complexity will be log n. So when so let's say if you want to add 10 numbers together, right? So you'll first add 5 numbers uh, in the left and then another 5 numbers in the right and then just join them. So that is divide and conquer. But divide and conquer actually works very slowly. What I mean is, if there are two numbers, right, it will make pairs of two elements, and then just keep adding them until you get a single element at the end. That's what is an example of sorting algorithm that uses divide and conquer pattern. What is the time constant in worst case? So much as I said earlier, right? Divide and conquer is actually to divide your uh, whole problem into equal steps, right? And merge sort actually does it in L log n. Actually, it's a very easy question. Why did I wrong it? Let's ask ChatGPT. If a problem is in B complete and another problem B can be reduced to problem A in polynomial time. So we are seeing a problem from problem B in some time. We are actually going into problem A itself. So at the end we are again getting NP complete only, right? So see, problem is NP complete, right? And after solving your problem B, you again come to problem A, and then problem A is again NP complete. So the answer is simple, NP complete. So yeah, I guess I just got confused by this part. Problem B can be reduced to problem A in polynomial time, but I didn't see the fact that it's actually going into again problem A itself. How many edges are required for a graph with n vertices to be tri-connected? Have at least three bi-connected components. Now I didn't know what bi-connected means actually, so let's ask here. How many edges are required for a graph with n vertices to be tri-connected? Have at least three bi-connected components. What is bi-connected component? Bi-connected component is the maximum subgraph in which any two vertices are can identity. Okay, let's stop here. We will read these answers later. Try connected graph.